Hi guys, today we're going to do nuclear magnetic resonance for carbon-13. See here, we have done proton already. So this, let me highlight first. Okay, come on. Okay, we're going to do carbon-13 NMR. It's very similar to hydrogen, but it has got a different scale. As you can see from here, from data booklet, see now, the chemical shift bigger, okay, 50, 0 to 50 as you compare for your hydrogen, right? It doesn't go past 12, no, okay, or 13, okay? So it's a different scale, right? The TMS is a different scale, okay? Now let's go to here again, right? It's very similar to hydrogen. Let me just give you a bit theory, right? So carbon-13, remember carbon has got a few isotopes, carbon-12, carbon-13, and of course carbon-14, which is, this is your radioactive, okay? Radioactive. Is this one I'm talking about? Okay, it's about 1% naturally occurring carbon, okay? And this fellow here, for carbon-13, there is half a spin, okay? Plus half and minus half, just like your hydrogen. So if you put the field here, okay, those which are aligned with the field, right, are lower energy. Those which are against the field are high energy. Again, they're split into two different levels there. So to flip the carbon-13 nucleus, again, you will absorb what? Radiation. E equals to H frequency. So now this is the frequency measured in Teslas. Okay? So the bigger the split, right? That means that the more the nucleus will feel the external field. Okay. So like here, you look at here. Okay. Now for this case here, for your TMS, right? The carbon here, I think will have the most electron around here. Okay. Remember now, of course, it's bonded here. Hydrogen will have some of this, right? This one here. There are 4 of them, and because silicon here is lower in electronegativity than your carbon, right? So it doesn't take any of these electrons here. So electrons here have shielded the most. So put an external field here, okay? Right? These electrons around carbon will block the external field. So it will feel only very small amount. So it will split into very small field here for this one here. So from here to here split. E is equals to H frequency. So the frequency is a small. So it's a small. Let's say it's a 1. Okay. Now you take this one here, this compound here, where I replace the carbon here, or silicon here by carbon. Okay. Here's silicon. Now carbon is of course more electronegative than silicon. So you pull some away from here. So the electrons around here will be lesser now. Okay. Less than here and here. So less than here, that means I put the same external field here. This will feel more of the field in, so it split more. So to jump here, E is equals to HF1. So F1 will have a higher frequency. That's why I say here. Okay. So 0 is for who? It's for TMS. It's for the carbon here. Okay. So any carbon, like here is CH3, like here, this is CH3, joined to a carbon, right? This joined to a carbon here, right? So this carbon do take away some electrons from here. So it is more de-shielded. It will feel more of the field, so it will give you a value here, right? Means you need more energy to flip this carbon here. If I've got this carbon here to 2 hydrogen only, and where is the carbon and carbon? So some pull and some pull in it. So of course it's more de-shielded. It means less electrons here. So you feel more the field. So space is bigger. No. So from here to here flip, energy 3 equals to HF2. So it's feeling more, isn't it? So it go make more. Okay? To 40, 30, 40. Of course, if there is more and more carbon here, right? So this carbon here, remember I'm talking about carbon and not hydrogen, okay? Right? This carbon here, well, pull electrons here, pull here, pull here. That means you have less electrons here, right? So the same external field here, it will feel more of the external field, so it's quite big. comparatively. So it may go to 50. So from here to flip up to here, the energy, let's say 5 is equals to HF5. The F5 here will be 50. Yeah. So that's why this sp3 carbon, right, it's a range from 0 to 50. Okay. So in this case here, like here, right, the C here, the H here, H here, right. This went to a double bond, which means this also like withdraw electrons. That means they will cause this the carbon here, right? The carbon now, hydrogen carbon here to have this 10 to 40. And of course now here, you can see, right, to a C double bond O. Here I put on C double bond O. Okay, right. It means of course this double bond O will withdraw electrons. See, right? Now this is for your ketone. This is ketone. I put again, I put the red color better. Clearer. Put ketone, red color. This is a ketone, carbon here to ketone. And this carbon I'm talking about, okay, this carbon, see this carbon, okay, joined to a carbon with a ketone. So of course this one here will pull electrons, right? So it will be shielded here. So you'll feel quite a lot of the field. So from 25 to 50, of course, in here, I got this carbon here, which is the NMR, to a carbonyl here, plus another oxygen here. So pull here, so of course one will be more exposed, so with 50 here. Around here, you cannot get exactly one, okay, because of all the side things here. Similarly, for nitrogen and so forth, you can see here, of course, chlorine here will pull, of course, because of the high electronegativity, will pull here, it will expose most of the field here. So 30 to 60. Now it's very iffy, now all it's about the same, but which means you must be able to catch it. This is quite common. This is alcohol. Okay, that's alcohol. Carbon. Remember, the NMRs for carbon are not hydrogen, to oxygen and to hydrogen. So oxygen directly connected to here, pull here, all right? So be highly deshielded. Okay, so from 50 onwards. Okay, now here of course is the carbon to oxygen, same as here, oxygen, and to a carbonyl group. This is of course is ester here. Okay, so to 70 here. This is quite common. Okay, carbon for a alcohol and carbon to an ester. Now the other one, of course, is is a double bond. Double bond and benzene. This is the range you need to know. This is the first one to go 100. 101 to 160. The largest is not carboxy acid as in your hydrogen. It's your aldehyde and ketones. The largest here. Take a note. About 200. Okay. The next, of course, is your carboxy acid and your esters. 160 to 185. The carbon here. See? The carbon here, in this case here, for this case here, I draw it for you. This carbon. This is your carboxy acid carbon here. Okay, this carbon will have an NMR of 190, around 190. It depends on what groups are here. Tesla. This one here, which is 4 C double bond O, and it was R. And this is R. R is a C, isn't it? Right? So you pull electron as well. Right? So of course it will give you a bigger one, which is 185. Okay? Triple bond, this one of course a very high electronegativity, so 100 to 225. Okay? Now this is a general idea about NMR for carbon-13. Now let's see how it actually come to play. Okay? So same as your as a proton NMR. Okay? But of course the values are higher. Okay? All right, now let's look at the examples here. You can read up all these things is from one of the people in the net. Okay, now here. Okay, let's look at here first. I did something here, so make it faster. Okay. Now this is carbon-13 NMR for ethanol. So ethanol here got two types of chemical equivalent carbon. See, one here and one here. Okay, so 0 is a TMS. Okay, this is 0 here. All right. So of course, this carbon, now there are two lines in experiment. NMR, you get two lines only. Why? There are two types of chemical equivalent carbon. So which one is further down? That means which one is more deshielded? Of course, next to the oxygen, which is more electronegative. So this carbon here we have this is about 58. Okay, 58 Tesla. So this one belongs to the COH carbon. Okay, so 58 here. Sorry, here. Okay, 58. Right. So this is a more deshielded carbon. So further away will be this one. This one here. 18. Okay, right? Easy, isn't it? Right, easy lah. Okay, next one here. All right, now here. This is your name here. Okay, is well 1-methyl ethyl propanoate. Okay, you know propanoate, 3 carbons, right? Propanoate. Okay, ethyl methyl propanoate is this one here. This is ester group. Ester group. Let's put it here. Ester group propan 3. Okay. Okay, 1 ethyl, 1, 2. Methyl C3, C3. I draw the other way. You can see here is they draw it in the other way. Okay, so the 2 here. You can do either way. Okay, let's take this one here. Okay, you got here how many peaks are here? Now remember this is 0. This is for TMS. This is the most shielded. Okay, the carbon most shielded. Most shielded means that it will feel the least of the external fields in, so it's blocked out. So it's a small difference in energy level. Okay, this is the most deshielded. Look at all this. Which one is it? That is 170. Well, let's say 100. I put here how much? This one here is. I didn't put here. I think they put something here. Never mind. Let's say here we can estimate. Okay, 175. Let's say. Okay, 175 Tesla. Okay, which means the highest here, 175. Of course, you check your thing here is now this is ester, yeah, ester group, see now, ester group. So check your ester. Ester, here. Okay, 185, 165. So around this area, it means 175 is quite accurate. Okay, so this is ester group, the carbon with the ester here. Okay, so this peak is due to now. Remember, the height of the peak doesn't tell you the amount of carbon. It doesn't. This one, okay. Unlike the hydrogen, the height, the area under the curve or whatever, those peaks will tell you the number of hydrogen. But here doesn't. Only the TMS will tell you the type of carbon. Okay, right? They don't. Here will tell you the number of carbons. Right? So this one we have dealt with. Okay. Now next, of course, which is the most shielded or deshielded, is the carbon next to oxygen. Okay, right here. Okay. CO. And CO here is not to a hydrogen here, which is alcohol, but to another carbonyl group here, which means to a carbonyl group. Now here I got one. Now here remember it's about 68. This is the one here given. Okay. So next I've got 68. Teslas. Okay, now it's a C to oxygen. Okay, C to oxygen. Is that not, sir? This is ester, is it? Yeah. It's not. So around this area, yeah, 50 to 70, which is correct. 70, of course, the one, the bigger number, because this is it's got 2 oxygen. Okay. So here, of course, is what is how much? 68. Very nice. So this is your C to the single bond oxygen. Okay, 68. So we solve this 2. Now come the other 3. Right. Now remember, you see the distance it has got. Now this one here. Okay. This carbon here. This carbon here. Okay. Carbon here to one carbon to another carbon to a double bond here. See now. Okay. Now this is the only electronegative filter that can pull the electron from this carbon. Okay, we're talking about this carbon, not this carbon, this carbon. Okay, so now compare one to this carbon. This carbon straight to the carbon with the double bond here. That means this carbon will be more deshielded. Yeah. We have a higher Tesla, is it? Higher chemical shielding. Okay. Now look at the other one. Okay. Now I got 2 more here. Now this one. This is the same. Enough ink. Let's try again. Okay. This carbon, okay, right? Is a carbon here, right? Carbon joined to one carbon here, joined to one oxygen here, yeah? So this is the same thing, carbon to oxygen here. So this oxygen is the only fellow which is putting electrons. So you compare these two, this carbon to carbon, these two, think about the O, these two carbonyl group. Of course, carbonyl group is more powerful, isn't it? Okay, so you take on the 28 here. Okay, so this one here. So it's 28 Tesla. So it's a carbon to a carbonyl group. So this one here takes this value, 28. Okay, and of course this one here, carbon to oxygen, takes this value here. Okay, which means, okay, right? Carbon, it's not here. This further, the two of them here. And this is the last one, of course, the furthest away. This is 10 Tesla, which is your CH3 right at the end. Right? So that's how you figure out which peak is for which carbon because of the different types of atoms of electronegativities. Right? Now let's go down further to other examples, right? At the here. Of course, as I said here, TMS, this is the most shielded, right? So you have 0 Tesla because silicon is less electronegativity than your carbon. Okay, let's go down to right down here. You can look at the rest at the top is the same one. Okay, this is better. Okay, now this one here. See? Okay, now this is the molecule which has got double bond, right? Can you see? So now because this double bond here, so now can you see that this is a what? A ketone, is it not? C double bond O to a C and to a C ketone. Ketone are the highest one. See? 200, around 200. Okay, 200 Tesla. Right? Ketone. Can you see how? Ketone. So it's good to be aware of this ketone. Right? Here. Ketones. No. Here. Okay, ketone. See now. Aldehyde is here. Ketone. Ketone, but here 220, right? Depends on the environment. So here we have 200. See now. Okay, which means it's a ketone. That means this carbon here. This carbon here will give that figure, will give this speed. Okay? Right? Because of high electronegativity of your oxygen, de-shielding the carbon here. So we are done with this one here. First one. Now, when you see a pair, okay, of about 120 to 140, okay, it's normally an alkene group. See, alkene group. Okay, alkenes. 110. Okay, of your benzene is 160 to the furthest end. So the range, 110. From 100, starting one is always double bonds one. Okay, so the alkene group, the double bond is here, 100. Okay, here got 120 something. Let me see, 100. Yeah, 100. This is 125. Okay, see, 125. And this I put 138. Okay, that means these two carbons here. Okay, will be these two fellas here. Okay, these two carbons here. So which one will have the higher Tesla? Of course, the one nearer to the carbonyl, which means this one is here. Okay, so this one will be 138. The further away one will be 125 or upper 125 as well. Okay, okay. So the last one, of course, is the CH3, right? So the CH3 have got a C to a C to double bond O. Okay, now this one here. You can see it's around 0 to 51. Okay, you can see a C3 to a double bond. You can check it out here from your table here. Okay, like here, right? Here, C, this HH, HH, right, to a C double bond O. Okay, so 25 to 50. See now, okay, you can see from here. So here's what? How much here? Here's, well, 25. Okay, just nice, 25. Okay, for this further here. this carbon here. Okay, all right. Now let's go some more here. Okay, finish here. Now here. Oh no, this is the one done this time. All right. Okay, go over it over yourself lah. Okay, now this one here. I got two isomers here. These two fellows here have got the same molecular formula, C3H6O. Yes, now you can see 3 carbons, 6 hydrogen, 1 oxygen. Here 3 carbons, 6 hydrogen. Now of course this is your propanol, this is a ketone, this is aldehyde. First thing, of course, this carbon here. This carbon here. These 2 carbons, of course, we have the high Teslas here. Of course, you can distinguish from here. Got only 2 peaks because these two carbons are chemical equivalents here. But it's got 3 peaks. 1, 2, 3. So that's the easiest way you can tell the difference. 2 peaks and here 3 peaks. But to tell the peaks, the readings, right? Because this carbon here, double bond here will be the highest. I told you ketone is a very high value, isn't it? So I put here 220. You can see from here ketone. Okay, ketone here, right now. Okay, this ketone is it. RCOR is it. Ketone here, the carbon with the double bond here is 220. Aldehyde is 190. See now. Okay, so you can see the difference here. Okay, so this I told you here. So aldehyde is 190. So is 220. Okay. Now next, of course, is this CH3 is the same. So a C, like again the CH here, 1 to a carbonyl. Same as now, isn't it? Okay. 1 to carbonyl. What they put down here? Here, this now. Okay. See, to a carbonyl. 25 here. CH3 to a carbonyl here. Carbonyl here. 25 to 30. Let's say 50. I say that's 30 lah. So here's 30. I put here 30. Okay. So the 2 of them the same. 30. Now here, CHH to C. Of course here much more than 30 or maybe 40 actually, right? Because this is not a H, it's a C. Right now. Okay. So here you can see it's 40, and of course this one is CH3. This one is to a C here, 0 to 50 or 15. It all depends on that. Okay. So the 3 peaks here. Got it? Okay. Next one. Now here you got there are 4 alcohols. The molecular formula C4H10. So 4 possible isomers here. And which one produced the carbon-13 NMR spectrum below? Now here you got how many peaks? 3, isn't it? Now let's go some. Now in this case, if this is the formula, there are 4 peaks. That's not. Because there are 4 different chemical environment carbon. So how many peaks? 1, 2, 3, 4 again. 4 peaks. How many peaks? These 2 are the same, isn't it? The 3 peaks are bingo. So how many peaks? These 2 are the same. So 2 peaks only. So it is this one. So how to explain these peaks here? Very simple. Now it's best if you can draw out the display formula. Okay, H here. It'd be clearer if you brought the display formula. C H here and H here and OH here. Okay. And CH2 here is a CH3 and a CH3, just rather easier. Okay, right? So which one do you think will give you a 70? Obviously the one, the carbon next to the very left 20, something like oxygen here. Okay. Oh, this is alcohol. This is 70. 70 Tesla. Now check. Okay, alcohol, right? Alcohol, where's alcohol? Alcohol is here. Okay, alcohol. That's not. Okay, 50 to 70. Of course, if there's carbon, this is all hydrogen. If there's carbon here, that means you put more. So this is the one here. 50 to 70. Of course, here we got 70. So this is the first one. This belongs to this carbon. Okay, this carbon here gives you the peak. Okay. Now next one, which is the one here. Now remember, the height don't tell you the number. Okay, they don't. This is the reading here, the Teslas. The chemical shifter will tell you what type of carbon is it. Of course, now this one here, right? The closest. This is carbon to oxygen. Okay, right? This one is carbon to carbon to carbon. This is further away, isn't it? So of course, this one will give you this one here, which is 30. Tesla. So this one would give you 30. The further away, which is about 18 or 19, 19, okay, right? Well, of course, these two carbons, okay. Okay, easy, isn't it? All right, let's go on. Okay, this one here. Now, see, the involved isomer C4H10O, which is an alcohol. Now, this, of course, is not in the syllabus, it's actually ether, right? These are ROR. Because there are 4 carbons and only 2, that means that it must be like a mirror image, okay? So you must use a brain and think, no brains too bad, they're going to B levels. Okay, so like this, right? So you have to know from that, right? So got here, of course, this carbon here is next to the very electronegative oxygen here. Of course, it will be taking the higher chemical shape then, 65. See, these are further away, take the 15. Cannot, okay? Remember the height, don't tell the number. Okay, very simple then. Okay, now this one here, right? Now this one here is this one. Okay, I think we did this now. Yeah, never mind. Okay, we did this just now. Right, remember this alkene. Okay, right. This is of course for your ester here. Okay, here and so forth. All right, we did this just now already. Now these are other examples. Right, to do it's a very short video. I just want to do some past questions as well. The next one we do is mass spectrometer, and then followed by chromatography. Okay, then we finish off all the analytical chemistry. Now this big molecule here, right? Remember C5H10O2 here. How many chemically equivalent carbons are there? 1, 2, 3, 4, 5. 5 lines. 1, 2, 3, 4, 5. How do you identify which one? Of course, this carbon here, this is the one that's nearest. Is the carboxy acid. Yeah. I told you carboxy acid is the second highest next to your ketone and aldehyde. See here? Carboxylic acids. Yeah. Okay. Which is about 160 to 185. 185, of course, is for your esters. Okay. You don't need to memorize it. You just to be aware of such a thing. Okay. You need to refer to it during exams. So 160 around here. They didn't give the value, they don't care, okay? So this is for the carbon with the carbonyl and for the acid group, you should know, okay? Right? Now, of course, next one here, nearest will be this one here. This one here will be, of course, the next one here. This one here will be, of course, the next one here. And of course, the last one will be this one, which they told you about, 13.1. Simple, isn't it? The distance from the electronegative substance. Now here, right? C5H11Cl. They give the molecule here. Chlorine is the electronegative substance, okay? The CH2. Remember chlorine here, you look at CH and chlorine here is here, okay? To chlorine here, see here, right? CH and chlorine here, right? 30 to 60, okay? Because of the chlorine here, it's not 0 anymore, right? Because of the chlorine pulling electrons away. So 36, 60, of course, here is quite around there, okay? So this, of course, this carbon here with the first one here. Okay, here, sorry, here. Okay, so this carbon, right? So the next carbon, which is nearest to this one, of course, this one here. So this next one here. And the last carbon, of course, the 3 of them same will be this one here. Okay, very simple, isn't it? All right, let's go more. Also quite simple. This alcohol, right? Carbon next to alcohol will be the highest one. Okay, well, you can see here, alcohol is around, where's alcohol? Yeah, here. Okay, 50 to 70. Okay, right, to 70. So it should be 50 to 70, and maybe 60 there. Okay, 60 here. Okay, so the next, of course, is this carbon here, which is this one. Okay, the last one, the lowest, of course, is this one, which is the one that they point out. Okay, all right. Now, again, you can see now there are 2 OH groups here. This is your higher one, which is your carboxy acid. Here, the alcohol is here. The last 2 CH3 is here. Okay, here. TMS. This is a TMS. This is 0. Okay, this one, of course, guys. This one here, right? This one here is this one here. Is 2 here. Okay. Okay, similarly here, all right, This one, of course, carbon here is this one here. This carbon. Okay? Right? Now there's 1, 2, 3, 4. Okay? 1, 2, 3, 4. Okay? This will be the last one because it's the furthest away. Alright? Okay? This one is next to the oxygen. It's next to the carbon. So this one will be next to oxygen, will be this one. Okay? This one here. This one here next to the carbon. Carbon is this one. Okay? Now let's look at some more here. Again, you see a double bond here. So a pair. Right? So of course this one here with the carbonyl here is this one here. Okay? Now turn next to this one, what feel the most in it? This will be this one here. This one will be this one here. Of course this one will be this one here. This is a TMS. Okay? Right? Cyanide very high. Okay? CN very high. Again, that is very high because it belongs to your amide. Now let's look at the ring kind of structure. Now there are how many types of carbon here? 1 here, 2, same, 3, and 4. Okay. Normally the last one here is hard to see one. Okay. Right. Okay. Now, so the first one, of course, is this one here. You put here 6 here. Okay. Next to the carbonyl, which you can see carbon next to the carbonyl. It's right here. It's a carbonyl here. 25 to how much? Let's see. 25 to 50. So, okay. Right. 25 to 50. Because here is hydrogen, there's carbon, isn't it? There's carbon here. So this is the one here. This is this one here. Okay. This one here. Right. Right. Now this one here, the small peak here. Okay. Is the, let me see, I think it's this one. Not very clear this one here. Okay, now the carbonyl, ketone. Ketone is where? Ketone here, 220. Probably down here. It's on here. It's on here. Okay. Right. Okay. Now next one, of course, nearer to some of these two, right? These two will be this one here. And the last one should be the small one here. You can see that here. Okay. Okay. Right. So as I said, ring structure. Now this is not benzene. This is all single bonds. Okay, guys. Where's the further? No, it's not. Sorry about this. Okay, now remember this is all single bonds. Okay, now this is not a ring, right? This is all single bonds. sp3. Now here is a ring. Here's a ring. Okay, so a ring for the carbon in the ring it should be quite high, isn't it? Right? It's like this one here. Okay, right? If it's just a normal saturated ring, sp3, it should take this kind. Okay, this side here, right? This one here, 0 to 50. Okay, so because it's a benzene ring, a phenol ring, right? It should be quite high like here, 100 something. See now, 100 something. Where is the further here? Okay, 110 to 160. Okay, so it's 110 to 160, which is around here. It's not here. Okay, so this will be of this kind of things here, right? And this outside here. Okay, this one of course is 51.6. Remember the carbon next to the oxygen, right now. Remember, right, to a ester. Okay, carbon. I can say here, carbon. Yeah, carbon. So next here. So here, carbon next to the. Oh no, sorry. Yeah, carbon next to the oxygen to the. Sorry. So 50 to 70. Okay, 50 to 70. 50 to 70. 51.6. Okay, so this will belong to this carbon here. Okay, so all these lines here. Okay, right? There should be 4 lines here, right? You can sometimes see 3 lines, don't care. So now, of course, this carbon here is your ester, should be this line here, okay? Ester, you can see the carbon with ester here, carbon ester here is this one here, 1 here, okay? 185, 185, so here's what 185. And this belongs to this carbon, okay? Right, double bond. So now here is 1 closest, right? So it should be this one here. Okay, the carbon here. Now these 2 are chemically equivalent, okay? Right, so you take this one here. Wait, let me see. This one should be this one here. I don't know how they do it, okay? This one should be. So the small line sometimes you can't see one. So if I put this one here, this one should be this one here, okay? Right now, but this one here should be this one here, and the next 2 here should be the one here. So the furthest away one will be somewhere here. They didn't show it, okay? So how far away is from the electronegativity substance, okay? You can see here, okay? Right? So these 2 are this one here. So 1 more here, they didn't show. Never mind. Okay, you can see here, right? This one is, see, this one here, okay, will be this, the small peak here, right? Okay. Now I want to go now to past year questions. These are all can look. It's quite simple. Okay, past year questions. Look at page 40, 44. I only finished half an hour essentially. 44. Okay, 44. Let's do it slowly, okay? Ethane dioic acid is ethane dioic acid. If you this one, they include all your organic chemistry now. Okay, now this is ethane dioic acid. Okay, right? Dioic means what? 2 carboxy acid. Ethane means 2 carbon. 1, 2. Okay, this is the dicarboxy acid converted to ethanol. See, ethanol. Of course, use a PCl5, isn't it? Okay, right? PCl5. Suitable region, PCl5, of course, or PCl3. Okay, normally it's PCl5. Okay, so now you get this one here, right? This one, of course, is the formula will be C double bond O, and it's a diacyl. Means before, isn't it? Diacyl. I don't know why this thing is like that. Okay, do again, and it comes out. Okay, diacyl. Okay, so the bifunctional group here. Obviously, if you were to put your ethanol, remember it gives you your ester, isn't it? If you have a problem, right, draw it out in exams. Draw out the whole thing. Cl here, and draw the alcohol facing the functional group to be boxed out. Okay. H and O and CH3. Remember, from ester, as it come out, right? HCl comes out. It's still condensation. As long as the molecule comes out. Okay. So of course this one will be CH3, C double bond O, why not? Yeah? CH3, oh, sorry, here's O here. Okay. And there's O here and CH3. You can see here 4 oxygen, right? 4 carbons, right? 6 hydrogen. Okay. Here, of course, now here is very tricky, because this is a ring. I'm going to draw it here. Okay, I draw it here, just to show. Okay, here I draw it here. Okay, now remember, use your brains a bit. Draw in a way as you can see clearly. Now this is a diamine. There's one question came up before. Of course, you didn't do that. N to C to C to N. Okay, now, yeah, I'll draw like that. Because when your box has become a ring, this is what they want. I'm going to use red color. Okay. Now, this comes out. Okay? Condensation. Okay? So what will form, of course, is carbonyl here, right? Now join to what? Nitrogen here, H here, C here, see nicely, 6 ring one. Nitrogen here, and this of course what? Here and H here. Do you see that? Beautiful, isn't it? You can't do this, then you're dead lah. You fail lah. And this what kind of bond is it? I put another color. What kind of bond is it? Anyone? Oh, I hear some people say, oh, of course, peptide linkage there. Right? Here. Peptide linkage or amino linkage. Yes or not? See not here. So this is the one here. Okay? So now it says here, now when ethynyl chloride reacted with silver ethanoate, this is interesting. It's good to draw such things up. You have not seen this before, I'm sure you haven't seen it before. Right? But it comes up in exam, so you better be sure that you know how to deal with this kind of thing. So what you do is, of course, this one here, you don't know the structure. Okay? Ethane is, you should know this one, ethane duate, which means this has got this structure. Okay, it's just a salt, that's all. Minus Ag plus. Okay, it's a salt. You've done it before in your sodium ethanoate in your titration, AS. Of course, you forgot lah. Okay, so epoxy ethane, now this is your solvent. This you will learn later in your solvent extraction. It's an ether. Okay, right? It's ROR sort of deal here. Okay, right? Low temperature and oxide of carbon. Oxide of carbon, that means contain what? Only carbon, oxygen. This one here. Must understand. They tell you the hints. L is formed. The molecule L has no dipole moment. That means that everything is, you know, well, equal out. Has a molecule of C4H6. We haven't seen this before. Okay, so blah blah blah. All right, ethynyl chloride. This one here plus ethynyl chloride. Remember now, plus. Draw it out. Ethynyl chloride is what? Ethynyl chloride. It will give you some hint one. Cl and C double bond O Cl. Okay, so this plus this will give you. They say C4O6. It's all here one. Okay, now wait a minute. They go step by step. Carbon 13 NMR solution of L. Okay, of L. Solution of L. That means L contains this one here plus what? Plus your ether here. This is your ether. Okay, ethoxyethane. Got two things here. See, a solution of this one and this one. Open your big fat eyes, okay? Okay, shown below. Right? So there got 3 peaks here. Very simple question actually. Just use your brains a bit. Use the data booklet to say in the boxes below the Teslas or the chemical shift values for the peaks. Due to the carbon atoms in this one here, of course, now this next to it. Remember, these are the things here. Right? So oxygen to carbon. Which one? Which means which one? This carbon, which one is higher field or bigger delta positive? Of course, can see this one here or this one, right? First cannot be this one. See, carbon to CH3 to oxygen. Full. Carbon to oxygen. Okay, here, right? See now, carbon to oxygen, like here to O, here. Carbon to oxygen, not carbon to oxygen. Okay, I said carbon to oxygen. Now, of course, this thing here is for your ester. Now here is for your aldehyde and ketones. Okay, remember? So now is there an ether here? Ether here, no ether here. Okay, don't get. That means it's around here. Okay, this is the closest you can get. Right now, CO. Right, to C. Let me see here. 50 to 70. Okay. 50 to 70, which means yeah, okay? Right. Carbon to oxygen. It's not. This is closest to get. Carbon oxygen 65 to 65. Of course, it's to 65. That is the furthest away, CH3 to C. CH3 to C, of course, is 0 to 50. Right? Here. Right? Yeah. CH3. That's not. Okay, so 50. So obviously this one it will be from here. How much is 10, 15? So it is 15. and this 15. So these two are being accounted for. See? So what carbon is this one here? 150, 160, 160. Okay, 160. For 160, right? For 160, what kind of structure carbon has got? Now here got here. All right, see 160 is of a carbon now. That means it's of this one here. To a O, no. Okay, esters of carboxy. That means carbon to 2 oxygen. Just enough. Okay, 160 to 185. So carbon to 2 oxygen, which means this fellow here, right? The L, right? So the L structure will have the 160 parts per million will have this structure. Okay, now go back here, use your brains a bit. Now these two add together. Obviously, the silver chloride will come out, isn't it? Right? No more one. So come out. So what is behind is these two fellows there. So these two fellows will form 1, 2, 3, 4 carbons. Right now, 4 carbons. Right now. Okay? How many oxygen? 6 one. 4 here and 2 there. So you form a nice ring, man, baby. Form a nice ring. Double bond here. O, well, 2 carbon here. Double bond O. See now. Okay? Now this is the original one. Okay, to another O, to so use your imagination. See, this part here is from the acyl chloride. See now, this part here is from your silver, silver part here. Here, the silver, what do you call it? Silver ethane dioxide. This part here. Now, does it fulfill the thing or not? Okay, remember, it's 160, isn't it? Yes, this one here, yeah. See? I want O. Yeah. Can I say it? Secondly, is neutral. Pull, 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 pull. See, this is the structure of L. Nice, isn't it? Yeah, hold on. Wait, Okay, now it was just interrupted. Okay, now this is the formula of your L. Now it says here, when pure L is reacted with excess of methanol, mixture of 3 compounds is formed. Now don't jump and do it yet. Okay, so remember methanol, right? Now look at this and this, right? Now more information are given later for you to consider. M is formed. Okay, M is formed. Right, as one of the products when N and O is heated with aqueous acid. That means aqueous acid heated with acid, which means what? Hydrolysis. Right? Hydrolysis. Okay, that means something in here that undergo hydrolysis. Now, what can undergo hydrolysis? Is there are 2 you learn, amide and ester linkage. That means it must be ester here. These 2 must have esters. Okay, so now you look at here, back here again, right? So this whole thing will react. Okay, C here, 4 here, and 6 on. So see, if this react, which means some parts of it will give you now. If there's 2 here, right now, okay, 2 here and 4 here, right? That means this part here. I'm going to use blue. So you try to figure out this part here, right? See, it cannot be running anywhere. Right? That means the H here. This means the M here, right? The M here, right? It has to come from the products of this one here. So M here, if it, like this one, it should be like C double bond O and H, right? A good example with this one here. It's not right. Right? When you heat it now, of course, now this one N here, 3 carbons here, it must have 3 carbon, 1, 2, and 1 more carbon, right? 1 more carbon, and then the 4 oxygen here, right? 1, 2, 3, 4 oxygen here, and so it's 3 carbon. That means it will be for N, right? N it should be 1. Okay, 3 carbon 1 must have this one here. Okay, it must here, and join to one carbon here because it's methanol. That's not. So 3 carbons, and of course, O here, and of course, now there are 4 hydrogens that must be joined to H here. So this must be M, this must be N. Okay? So now C4, C4 means C4 here. Okay? So C4, it means must be here coming out. So C4 I put down here. Okay? 1, okay, must have this one. Okay, because it's the main part. C4, okay, O must be here. Okay, to another CH3, to another CH3. So it's like try and error, but you can actually see later, you can prove it later. Okay, C4, 1, 2, 3, 4, H6. So this is supposed to be your what? Supposed to be your O. Okay, then the table gives information of the carbon 13 of M and N. So M, M is your carboxy acid. Okay, carboxy acid. Okay, here, carboxy acid. Here, I put blue lah, so can you see clearly blue. Okay, here, carboxy acid. Okay, which is 160. Okay, 160. Here's what? 162. Bingo. So this one here will be this both of them here, 162. Okay, so here is 162. That means it must be the carboxy acid. 162. It's not N. Right? 53 must be this fellow here. 53. It's not. And 160 must be this fellow here, your ester. 160. That's not. Now here, of course, 160 must be the ester. 160. 53 must be this one here. 53 and this one here. Okay, so now you got all the structures here. Can? Right? Then finally you draw L. Can, Okay, very interesting, is it? Now let's say here. Another question here, we look straight in here. I'm going to in here. Samples of bottles containing isomers phenyl ethanoate and methyl benzoate. Okay, if you want to draw it out, you have to know this is an ester. This part represents come from the carboxy acid. Just to remind you, carboxylic acid. Okay, the last part of the name here, O8, is for your ester. The first part here comes from the alcohol. Just to remind you. Okay, right now. So carboxy acid, which means here, if it's ethanoate, which means that is one. Okay, or you put this way, okay now, right? CH3. And O here, here's a phenol. Okay, it comes from the phenol group. Okay, right? And that's up here, methyl benzoate. Okay, benzoate, which means this one here. Okay, and benzoate means 6 + 1 carbon. It's a benzoate. And of course, here's a methyl CH3. So the two here, what's the labels? Isomers A and B. Okay, this can you see? So remember, right now all these big figures here. Okay, big figures here. They of course the small figures. Look at here, the small figures. Look at the small figures. The small figures are easy to deal with. Now, the small figures of course belong to this tree. Let's put red color. Okay, red color. CH3. CH3. Okay. Now this C here, H and H here and H here and H here. Trying to C, but O. C here's one join C, H here. Join to what? O. O more, see not? Okay. Right. CHO, see not? CHO and C to C. See different C, CO, CO, CO. CO here. Ester. C to O. Okay. Ester, about 70, 50 to 70. Right? 50 to 70. See not? C to O. Okay. About 50 to 70. Now, C to carbon, C to C. This is C to C and O. C to carbonyl, C to carbonyl, C to carbonyl here. C to carbonyl. Here. See now. Okay, I started it. C to carbonyl. Okay, 25 to 50, lower, isn't it? See the carbon now. Okay, carbon now, lower, 25 to 50. 25 to 50. Ah, it means this one. Yeah. So this is your 26. That means this is your isomer B. This is your what? Isomer A. Others quite hard to distinguish because they are about the same. Okay, so quite simple now. So B is this one here. B is your phenyl. Okay. Okay. B is your phenyl ethanoate. Okay, B phenyl ethanoate. Okay. So here, of course, you just put here phenyl ethanoate CH3, right? B is 26. It's 26. Is what? 52. Okay. Now, of course, the difference, of course, is this carbon here. It's 26, right? Now the carbon here. Carbon here is to carbon here 26. Okay. The carbon here. See, the other difference is these two. Big difference. Yes, no. Okay. And of course, the other big difference is, well, actually this one is a bigger difference. Okay, the biggest one. Okay, the biggest one belongs to what? The carbonyl group. The carbonyl group. Okay. Right. Okay. Quite simple. Right. 26. 169. Very simple. Just copy from there. It's 167. Sometimes it's very hard to tell the difference. Okay. Look at the marking schema. Okay. 26, 169. 26, 169. Yeah. Okay. 52, 52, 167. Okay. So this, of course, the answer. Right. Now, this one is later we can do that. Distinguish. Of course, to distinguish chemically, you of course hydrolyze this. You get phenols, right? Okay. Acid hydrolysis, you heat acid hydrolysis. Phenol, you add bromine water, you get YPPT, is it? Bromine decolorized YPPT, you can see here. Okay. Hydrolyze the acid, the ester, add bromine, decolorize bromine, YPPT. Simple, isn't it? Okay, now I finished on NMR already for proton and for carbon-13. The next one we do, of course, will be your mass spectrometer. And of course, the last one will be chromatography. Okay, goodbye, and I'll see you next time. All right.